3 AI tools now do what consulting firms charge 6 figures for. Still reading code manually? By the end of this video, you'll know how to map a legacy system faster than architects who've been there 5 years. Dr. Vera Nexus showed me something last month that made me rethink everything I thought I knew about understanding inherited code. She pulled up a codebase nobody had touched since 2009. 16 years of accumulated decisions, dependencies, and disasters. The kind of system where asking why does this module exist gets you a shrug and a ghost story about the architect who quit in 2011. The kind of codebase where every function name is a cryptic abbreviation, where the original design patterns have been buried under 7 layers of emergency patches, and where the comments contradict the code because someone updated one but not the other back in 2014. She mapped the entire thing in 47 minutes. Not documented it, mapped it. Every dependency, every dead end, every place where one function calls another in a chain so tangled it would take a human team 3 weeks just to draw the diagram. She could trace data flows from user input all the way through to database commits. She could identify which modules were load-bearing and which ones were vestigial remnants of features that got deprecated half a decade ago. Here's what you need to understand. Right now, there are developers spending 20 hours a week just trying to figure out what code does before they can change it. They're the ones everyone warns you about when they say, "Don't touch that file. Nobody knows what it does anymore." They're reading through functions written by people who left the company 8 years ago. They're tracing call stacks by hand. They're building mental maps that evaporate the moment they take a vacation. They're the institutional memory. And they're exhausted. They've become archaeologists instead of engineers, spending more time excavating the past than building the future. And while they're doing that, there are other developers using AI tools that do that same work in under an hour. This isn't about being faster at writing code. This is about collapsing the time between "I inherited this mess" and "I know exactly how it works." That gap used to be measured in months. Now it's measured in minutes. The people who figure this out first will become the most valuable people in their organizations, because they'll be the ones who can actually change things without breaking them. They'll be the ones who can confidently say yes when leadership asks if a feature is possible. They'll be the ones who don't need 3 weeks of investigation before they can give an estimate. Marcus Chen learned this the hard way. He's a back-end engineer at a logistics company, not a startup, not a tech giant, a company that ships actual boxes to actual warehouses using software written during the Obama administration. The kind of place where the production server is named after a developer's cat from 2012 and nobody remembers why. 6 months ago, Marcus inherited a payment processing system the original architect had left 3 years earlier. The documentation was a single README file that said good luck. The system handled $4 million in transactions every week, and nobody understood how it worked well enough to modify it safely. It was the kind of system where everyone just prayed nothing would break because fixing it might mean understanding it first. His manager gave him a project. Add the support for a new payment provider. Estimated time, 6 weeks, maybe 8. Most of that time would be just figuring out where to make the change without destroying everything downstream. Marcus did what everyone does. He started reading. He opened the main controller file. 2,000 lines. No comments. Variable names like proc2 and handle stuff. He traced one function call and found himself 7 files deep in a chain of dependencies that looped back on itself. He made diagrams on his whiteboard. He color-coded sticky notes. He asked the team. Nobody knew. One developer said, "I just try not to touch that part." Another developer admitted they'd once spent a full week tracking down a bug that turned out to be caused by a function that ran in a completely different service, triggered by a message queue nobody had documented. 2 weeks in, Marcus had mapped maybe 30% of the system. He could feel the clock ticking. He could feel his manager losing confidence. He was working late, coming in early, and still felt like he was wandering through a dark cave with a dying flashlight. Then he found Built. Builty is an AI tool that reads your entire codebase and builds a semantic understanding of what everything does and why it exists. Not just syntax highlighting. Understanding. You can ask it questions in plain English, and it answers based on what the code actually does, not what someone claimed it does in a comment from 2013. It analyzes control flow, data dependencies, architectural patterns, and even detects implicit assumptions that never made it into any documentation. Marcus pointed it at the payment system, gave it 10 minutes to analyze. Then he asked, "Where does the system handle payment provider authentication?" It gave him 4 files. The exact 4 files, with explanations of what each one did and how they connected. It showed him the flow from the moment a payment request arrived to the moment it got handed off to the external provider. It even flagged 3 places where error handling was inconsistent, including one spot where a failed authentication would silently retry forever, slowly filling up the message queue until the entire service ground to a halt. In 20 minutes, Marcus understood more about that system than he'd learned in 2 weeks of manual exploration. But here's the part most people miss. Stay on this for a second. This is the part everyone scrolls past. Marcus didn't just use Built to answer questions. He used it to generate a complete architectural map of the entire system. Every module, every dependency, every entry point. The tool created a visual diagram that showed him not just what the code did, but why it was structured the way it was structured. He could see which parts of the system were tightly coupled, which parts could be refactored safely, and which parts were held together by assumptions so fragile that changing one variable name could cascade into catastrophic failure. He showed it to his team. 3 senior developers stared at it. One of them said, "I've been here 4 years, and I didn't know half of these connections existed." Another pointed at a module and said, "Wait, that's still running." They realized they'd been maintaining mental models that were incomplete, sometimes dangerously wrong. Marcus finished the project in 9 days instead of 6 weeks. And when he submitted his changes, he knew exactly what would break and what wouldn't, because he finally understood the system. He could trace every side effect. He could predict every downstream impact. He wrote tests that actually mattered because he knew which code paths were critical and which were dead ends. Here's what you're going to do today, not next week when you have time. Today, go to Built AI, sign up for the free tier. Point it at the most confusing codebase you work with, the one everyone avoids, the one that makes new hires quit. Give it 20 minutes to analyze. Then ask it one question. What does this system actually do? Read the answer. Follow the connections it shows you. Look at the dependency map it generates. You're about to understand in 20 minutes what previously took 20 days. And once you see that happen, you'll never go back to reading legacy code the old-fashioned way. If this just saved you real time, subscribe. Next episode, we're showing you the tool that writes the documentation nobody ever wrote. This is where everything changes. Most people aren't ready.